Hello, this is Matt from Heaney Apps, and this is part 3 in a 7-part Saturday full game tutorial series where we will make the full iPhone game 7 Sides in Xcode using SpriteKit and Swift. So far we have our colour wheel set up, so we have the 7-sided shape in the centre of the screen. Each different side of the colour wheel has a different colour, and if we tap on the screen, the colour wheel is going to spin. In this video, we will set up the balls, so a randomly coloured ball will move to a randomly selected side of the colour wheel. We will test this and make our game do this. And once that's all working, we can set up the start of the game, so you have to tap on the screen to start the game. So by the end of this video, your game will look like this. So let's jump straight back into Xcode. So back into Xcode, and before we start, there's just one more quick thing I really want to say, just as a really quick audio edit. Now the plan for this series was to release a brand new video every single Saturday, so a new video in this series every week. Now, as I'm sure you've noticed, these videos are very long, much longer than I had planned. And I'll be honest with you, they are taking a lot longer to make, to record, to edit, to polish them all off than I thought they were going to. Now I will do as much as I can to get a new video in this series out every single Saturday, but I am involved with other projects that I'm contracted to do that need some of my time. So there might be a weekend or two without a video, just because I simply haven't had time to finish the video off. You know, I don't want to rush it and just get it out for the sake of it. I want the video to be as good as possible. So, just wanted to quickly say, if there ever is a Saturday without a new video in this series, I'm really sorry. The videos will be back and this series will finish here on YouTube. Okay, so now back into Xcode. And today we will be dealing with spawning the balls. Now the whole point of 7 Sides is that a randomly coloured ball will spawn in the centre of the screen and it will move to a random side of the colour wheel. So we have to spawn a ball. This ball will be a random colour and it will move to a random side. So into our game scene, and making sure you're outside of a function, I'll do this just after the prep colour wheel function, we need a new function, which we will call spawn ball. We won't pass anything in, open curly bracket, drop a line, and we now have a brand new function. And our code to spawn a ball will all go between these two curly brackets, and then all we have to do is call this function, so run this block of code whenever we want to spawn a ball. So let's take care of spawning the ball. Now just like our sides that make up the colour wheel, our ball cannot just be a sprite node, because our ball needs the property which holds what type of ball this is. So just like our side is a custom class which inherits from sprite node, so it's still technically a sprite node just with extra bits, side has a property called type. This will hold if it's the red type or the blue type or the green type or the whatever type. Our ball will also have this property, and then when the ball hits a side, we can just compare these two properties to see if the ball matches the side. So, just like we have a custom class for side, we need a custom class for the ball. So the start of this will be very similar to what we did in part 2, so we will smash through this. So for our new class, we need a new file, so file, new file, iOS Swift file, and we will call this ball object and hit create. And in our brand new file here, we will create the ball class, so we can then make objects which are of type ball. This class will inherit from SKSpriteNode, so it will still be an image object, but it will do a few more things. This will have the property to hold what type it's going to be, and we will add a few more bits as we go through this video and through this series. So before we move in and make our ball class, our files over here are starting to get a bit crowded because we have quite a few files now, and later in this series, when we make our main menu scene and our game over scene, we will have more files. So what we'll do, click on the ball object, hit command, click on the side object and models and data, because these 3 files are our custom objects and our custom types. Right click and we will do a new group from selection. This will put these into a folder which we will call objects, models and data. They're all kind of relevant, so we'll put them together. When we add more scenes, we will add another folder to keep this organized. But for now, this will do. So into our ball object.swift, and here we can now create the ball class. So we will import SpriteKit because this new class ball will inherit from skSpriteNode. So now, a bit like our sides, anything that is of type ball will technically still be a sprite node with a few extra bits. Now, just like the sides, this ball needs a constant called type, which will be a color type. So every ball will have a property which holds what kind of ball it is. Is it the red ball or the green ball or the yellow ball? Because this ball needs to have a type, we need our initializer, the code that will run whenever we set up a new object that is of type ball. Here, we will set up what type of ball this is. Now, for our side, we passed in the type that side was going to be, as I'm sure you remember from part 2. That way, whenever we make a side, we passed in what kind of side it was going to be. We could do the same for the ball, but remember, the ball is going to be a random color, and therefore a random type of ball. So what we could do in the game scene is select a random type for this ball, therefore a random color for this ball, and pass this in. Or what we can do is we can pass nothing in and do all the work here. And this will help keep our code so organized and tidy. And this kind of approach to your code will make your code so reusable. Because now, here in the ball, when we make any object that is of type ball, we can deal with selecting a random ball. That responsibility is on the ball to be random. Our game scene doesn't really care about making this ball random. It will just ask for a ball, and this ball will be a random ball. So before we jump in and do that, let's take care of adding that. Okay, so rather than passing in the type in our initializer, so when we make the ball, we will here select a random type. That way, whenever we add a ball, that ball will always be a random type. So what we want to do is, we want our ball to look at our list of types and colors in our wheel and pick one of these at random. So what we will do, we will generate a random number between 0 and 6. We will then use this number to select a random type from this list for our ball to be. So ball object, rather than passing in a type, we will say let random type index, and this has to be a random number. So we will say arc4 random %7. This will generate us a random number out of 7 options starting at 0. So now random type index will be 0, 1, 2, 3, 4, 5 or 6. It will randomly pick one of these numbers. Now, before we can use this number, this actually gives us our number in the wrong type. We want this to be an integer. So here we will say make that an integer. So just generate us a random number and give it to us as an integer. What we can then do is say take the type of this ball and set this to color wheel order and whatever is at the index of random type index. Now, when we spawn a ball, so this is the code that runs whenever we make a new ball, we're picking a random number, either 0, 1, 2, 3, 4, 5 or 6. We're then passing that in here. So if this picks 0, this will set the type of the ball to whatever's at index 0 on color wheel order. So it'd be red. If it generated 1, it would pass 1 in here. So this ball would be orange. Rather than passing in the type that this ball will be, whenever we spawn the ball, so whenever we initialize the ball, it is now making itself be a random type. So our game scene hasn't got to deal with passing in a random type. The ball can take care of that itself. That is something the ball will do. Because the game scene doesn't care about this ball being random. The game scene just cares about spawning a ball. The ball cares about the ball being random. It's one of the jobs that the ball has to do. So the ball is now making itself random. Now, as this inherits from skSpriteNode, we have to run our super initializer, where we pass in our texture, the color tint, and the size. And just like with our side object, how we said the texture, so the image, would simply be side underscore and then whatever type this side is, it's the same situation with the ball. All of our ball images are called ball underscore and then the type of ball. So if the ball is going to be the purple, the image is ball underscore purple. If it's the yellow ball, it's ball underscore yellow. And if it's the green ball, it's ball underscore green, and so on. So our image, so our texture, ball underscore, and then whatever type this ball is. Okay. And then we can set up our super initializer with an image. The color will be clear because we don't want that color tint. And then the size of this will be the size of the image. Okay, so we have now created another type for the ball. At the moment, almost identical to what we did when we made the side. Anything that is of type ball will have everything a sprite node has, and it can be treated in the same way as a sprite node, but it has an extra property. As anything that is of type ball has to have a random color, rather than passing in what type this was going to be, when we make the ball, here we are selecting the random type this ball is going to be. So we select a random type and set this to be the type of the ball that we're setting up, rather than passing in which ball we want this to be. We then use this to figure out the image that this ball has to use. So if this ball is of type yellow, use the yellow ball. If it's of type red, use the red ball. If it's of type green, use the green ball, because these images were simply called ball underscore and then the type of the ball. So for now, that is our ball class. Hit Command B to build, and we will now set this up in our game scene. So now here in our spawn ball function, we haven't got to worry about making the ball a random type or any of that. All we now have to do is say let ball equals ball. We haven't got to pass anything in. Now because the initializer in ball is making this a random type and setting the image for us, this will actually spawn a random ball. Now all we have to do is put the ball in a position which is in the center of the screen and add this to our scene, like so. So all the hard work for the ball is taking place in the ball's initializer. And when we spawn a ball, behind the scenes, we are picking a random type for this ball to be, and we are dealing with setting it to be the right image. Now that happens every time we spawn a ball, and our game scene hasn't got to deal with doing any of that. The game scene's busy with making our game work. So let's make the ball sort itself out over in the ball class. Here in the game scene, we'll deal with what the game scene has to deal with, which is spawning a ball, putting it in the center of the screen, and adding it. So just with that, when we run this, we will now have a random colored ball in the center of the scene. So let's test this out. For now, we will do this when the scene first loads up. So in our did move to view, after we've done everything else, we will run spawn ball. And let's hit run. And here, as you can see, we now have a purple ball in the center of the screen. If we run this again, hopefully we get a different color. We have a 1 in 7 chance of getting a purple one again. As you can see, it's orange. And if we run again, it's green. So a random colored ball is now spawning in the center of the screen. And this is random without us having to set this up to be random in the game scene, because when we make a ball, when we initialize the ball, we're taking care of it here. So whenever we make a ball, we pick a random type for it to be, and we figure out the image based on this type. So now when the ball is spawned, it makes itself random, and over in the game scene, we can just say spawn us a ball, and this will now be a random ball. And in addition to this ball being a random ball by default, as all of the balls will now be of type ball, all of the balls will also have the type property. So here we could say ball.type. And as a quick bit of recap, it is very, very important we have this for when it comes to comparing the ball to the side when they hit. So now all of the sides have a type property, which store what kind of side it is. And now all of the balls also have a type property, storing what type of ball it is. This will make it very easy to compare the ball and the side when they hit. Pretty cool, right? Now at the moment in our game, when we spawn a ball, it will just appear. In just a few moments, it will move, but regardless, it will just appear out of nowhere in the center of the screen. Now, I like to really polish things off. I like to make things look and feel as good as I can make them look and feel. So rather than just appearing, we want this ball to scale in. So it starts at nothing and it sort of pops into the scene. We will start this ball off with a default scale of 0. So it's so small, it's not there. we'll then make it scale in, so get bigger, so it becomes the normal size. Just to polish it off just a little bit. So what we could do is deal with all of this when we spawn the ball in the game scene. Again, just like picking a random type for this ball, this is something that the ball has to deal with. We could do it in our game scene, but the game scene will already have a lot of code, and we want every single ball to act in this way. So what we're going to do is back into our ball class, and we're going to take care of this here in our initializer. So we're going to add to this, because with this initializer, we're pretty much saying, when we make a new object that is of type ball, so pretty much whenever we spawn a ball, run this code here on the ball we are spawning. Because even though we're not passing anything in, when we spawn the ball, we're still running the initializer. Because this will make the object for us. So here, after we've taken care of all of the important stuff, we can polish this off. So we're in the ball class and we're going to affect the ball. So we want every ball to have a starting scale of 0. So as we're in the ball class, we will say self.setScale0. This means every single ball will now start at a scale of 0. When the ball is initialized, when we make it, set the scale to 0. So every ball now, by default, unless we changed it in the game scene, would have that starting scale of 0. We then want this ball to pop into the screen. And now what we can do, we can run an action on this ball from here in the initializer of the ball. That will mean whenever we make a ball, not only set a random type and therefore a random image, and set the scale to 0, we can make it do something straight away. So here we want an action called scale in. It'd be an sk action dot scale to 1 over 0.2 seconds. And then all we have to do is say self, so the ball that is being spawned, dot run scale in. So now, without doing anything in our game scene, whenever a ball is spawned, so any object that is a ball, it will be a random type, and therefore a random image. It will have a starting scale of 0, and it will get bigger, so pop onto the screen. And because this is in the initializer of the ball class, any object that is the ball will do this by default straight away. So now, in the game scene, we haven't got to change anything. We're still going to spawn a ball, but now every single time we spawn a new ball, that object, that ball, will do all of this. It'll be a random type and a random color, and it will start off with a scale of 0 and pop onto the screen. So what we're actually going to do, because the simulator can take a few seconds to kick in properly, if we spawn our ball from the did move to view, so as soon as the scene loads up, we might miss it. So we're going to move this, our spawn ball, to run in the touches began, like so. So now when we touch the screen, spawn a ball, and this ball will be a random color. It will start off being so small we can't see it, and it will scale onto our scene. Hit run. So now, click on the screen, and our ball will sort of pop onto the screen. Let's see that again. And because this all happens in the ball class's initializer, any object that is a ball will do this by default. We haven't got to make it do it, it will just do it by itself. Okay, pretty cool. Now, that's spawning a ball. But at the moment, our game doesn't do anything. The ball just sits there, and we want this ball to move to one of these sides. So this ball will select at random one of these sides, and it will move to one of these sides. Okay, so just like it's a random color, it will move to one of these sides at random. We then have to spin the wheel, so the ball hits the side with the same color. So, once again, we could deal with doing all of this when we spawn the ball in the game scene. But this is something the ball has to do. The game scene just wants a ball, and the ball's job is to spawn, be a random color, and to move to a side. So we will go back into our ball object, our ball class, and we'll take care of making the ball do this here. As we want this to happen straight away, we will once again make this happen in the ball's initializer. So whenever we spawn a ball, we want the ball to be a random type, therefore a random color image. We want it to pop onto the screen by scaling in, and we want it to move to a random side straight away by default. And we want any object that is of type ball to do this. So here, let's make a ball move to a random side. Now, just like when we picked a random color, we generated a random number and went to a list of types and got a type from that list. Here, we want to do something very similar. Basically, we want a list of all the starting positions of all of our sides. Our ball will then simply pick one of these positions to move to when it spawns. So before we can make it move to a side, we have to make a list of all of the starting positions of all of our sides and then pick a random position from this list. So game scene, prep color wheel. Once we've made our color wheel, we want to get all of the sides and put their positions into a list. For this, we have to set up a new list, a new array. We will be adding to this array here from our game scene and using it from our ball object class, so all over the place in our project. So because of that, we will set this up in our models and data file. If we have something here, we can access it from anywhere in our project. So here we will declare our array, side positions, and this will just be an empty array of CG points. As we use CG points for our positions, as it can hold both the X and the Y coordinates. So this will be an array of positions. And because we want to use CG point, we now have to import SpriteKit up here. So we can then use CG points in this file. So we now have this empty array that will store all the starting positions of all of our sides. Then when the ball spawns, it will just pick one of these positions at random and move to this side. So before we can deal with making the ball move there, we have to get all the starting positions of all of our sides and put this into this array. So hit Command B to build the project because we've added something in a new file. Game scene. Now we want to do this after our loop to make the color wheel, because remember our sides are sort of sliding all over the place in the process of making the color wheel. So we want to wait for the color wheel to completely finish making itself before we go get the starting positions. Because only when the color wheel has finished will all sides be in their correct starting position. So how are we going to do this? Well, all we really want to do is take all of our sides and take their starting position and add it to this array. So we want to run a loop through all of our sides. So how we would do this is, as I'm sure you remember, all of our sides are children of the color wheel base object, the big red square. They all belong to the big red square, and the only things that belong to the big red square, the color wheel base, are these sides. So after this loop, very important that you're after this loop here, we will run another loop. We will say for side in color wheel base, our big red square, dot children. What this is saying is run a loop. And this loop is going to go to our color wheel base, and it will run the following code on every single child in the color wheel base. So effectively all 7 of our sides. We'll run this 7 times, and each time we run this, we will affect a different child of the color wheel base. So a different side, and we will call it side. So anything we do in here, we will do to all of our sides. So what we want to do is get the position of each side. So let side position equals side dot position. So again, what we're doing, we are running through each of our 7 sides, running the following code on each. And in each case, we're calling each side, side. So do this for the first side, then start again for the second side, start again for the third side, and do this for all of the objects that are children of the color wheel base. So for all 7 of our sides. Because we are running this in turn on each side, we now have the position of each side. We now have to add this to our list. Now this here could lead to a massive problem, because remember, side belongs to the color wheel base, and therefore it has a different coordinate system compared to everything that's on the scene. And the ball is part of the scene. So just like when we made our side, we had to convert to the color wheel base, because this will be a position the ball has to move to, which is part of the scene, we now have to convert this back to it being in terms of the game scene, because the ball, which is part of the game scene, has to move to this position. So we call it position in scene will equal convert point side position from the color wheel base. This will go get that position, convert it back to being in terms of the game scene, and it will set that to position in scene. All we then have to do is take our array, side positions and add position in scene. So basically all we're doing is getting the position of each of our sides. We're doing this in a loop, so we're doing this to all of our sides, getting the starting position of each of our sides, figuring this out in terms of where these are in the scene, because these belong to the color wheel base, so they have a different coordinate system for their position. And because the ball is part of the game scene, we have to work with these positions in terms of the game scene, and we then added this position to our array. So now we have an array called side positions that holds the starting position of each of our 7 sides. All we then have to do for the ball, when we make the ball, is pick one of these positions and move to it. Back in the initializer, we will say let random side index, and again, this would be a random number, either 0, 1, 2, 3, 4, 5, or 6. Just like we did when we picked a random color, we need to make this an integer. And then what we can do, we can go to our list, which now holds the starting position of all 7 of our sides. And we want to get one at random. So let side to move to equals side positions and the side at index random side index. So this here will pick us a random point to move to. So to quickly recap, we declared an empty array which will hold all of the starting positions of all 7 of our sides. Then, after we have made the color wheel, we took each side, figured out where that side is in the game scene, and added that position to this array. As we're doing this for 7 sides, this array now holds 7 positions, the starting position of each of the 7 sides. Now, when we make a ball, we are picking another number, either 0, 1, 2, 3, 4, 5, or 6, and we're using this as an index number. So this array here now holds all 7 positions, and we're saying if our random number generator picked 0, go to index 0, so the first item on this list. If it picked 1, go to index 1 on this list. If it's 2, go to index 2 on this list. So effectively, we're just picking a random position from this list. All we then have to do is set up and run an action on this ball so it actually moves to this position. So let move to side be an sk action dot move to. We want to move to side to move to because this now holds the position of the side that we picked at random. And for now, we will say make this ball move there in 2 seconds. Now all we have to do is run this on the ball. However, we want our ball to fully scale in before it starts moving. So rather than saying self.run scale in up here, delete that, and we will set up a sequence. This will say run the action to scale in, and when it's finished scaling in, move to its random position. So let ball spawn sequence be an sk action.sequence square brackets because it's a list, it's an array, and this will be the order of actions we want to run one after the other. So we want to run scale in to make the ball appear, and then move to side to make the ball move to a side. Then just take the ball we're spawning and run ball spawn sequence, and that will make our ball spawn in, so scale in, and once it's finished scaling in, it will move to a random side. So all of this will happen to every single ball that we make. And here in the game scene, we haven't got to do any of that. And the game scene will just add a ball. This ball will now pick a random color for itself, so a random type for itself. It will make itself spawn in, and then it will make itself move to a random side. In our game scene, we can just say spawn a ball, and all of that will happen to every ball by default. So let's hit run and let's check this out. So tap on the screen, and we're going to get a ball, and it moved to a random side. Now it won't do anything when it's there yet, but a random coloured ball is spawning and it's popping onto the screen and it's going to a random side. Now as we have this set up to spawn a new ball whenever we tap on the screen, we can test this out. So keep clicking the screen and let's get lots of random coloured balls and let's make sure they go to a random side. So just click loads to test it. And as you can see, lots of different coloured balls all go into a random side. So now as soon as we spawn a ball, it's going to pick a random colour for itself and pick a random side for it to move to, it will pop onto the screen and then move to that side. Okay, so doing this too much will make the game crash because the balls aren't actually being deleted. They're sort of just sitting in their final position. But we can deal with that when we deal with our contacts between the ball and the side. Now, at the moment, we're making our ball appear whenever we tap on the screen, which obviously we don't want to do. So, at the moment, we are spawning a ball every single time we tap on the screen. However, we obviously don't want that to happen. We want the ball to spawn at 2 different times during our game. When the game begins and when a ball is hit a side and the ball and side are the same colour. So when the game begins and when you score a point. Now we'll be dealing with the ball hitting the sides in the next video, but now we will set up the start of our game. So we want the start of our game to be like this. When you move into the game scene, the game won't start straight away. There'll be a label that says you have to tap on the screen to start the game, and when you tap on the screen that first time to start the game, the ball is going to spawn. Then, every time you tap the screen afterwards, we only want to spin the colour wheel, not spawn a ball. So we only want to spawn a ball the first time we tap on the screen to start the game. So to do this, we need to have a way for our code to know exactly where we are in the game. Are we before the game, waiting for it to begin, or are we during the game? Because if we tap on the screen before the game, we want to spawn a ball to start the game, but if we're in the game, we only want to spin the colour wheel and not spawn another ball. Later in this series, we'll also use this for Game Over to tell our code not to let us spin the colour wheel at all when the game has finished. So what we're going to do here in the game scene, we're going to have a variable called current game state. And this here will tell our code where in the game we are. So what we could do is we could set this to be a number. Where, for example, if current game state is 0, this would mean we are before the game. If it's 1, we are in the game. And later in the series, we could add 2 to say the game has finished. And then when we tap on the screen, we would just say if this is 0 and therefore we are before the game, start the game. Change this number to 1 when we're in the game, and if we tap on the screen when the number is 1, spin the colour wheel rather than adding a ball. Now don't get me wrong, that could work. However, if you are a tool like me, I like to have about 10 different projects going on at once. And if we use this number, probably by tomorrow, I would have forgotten what this number means. So we don't really want to do this with a number because then we could forget and things could get very confusing, and that's when bugs start to come into your game, when things like this go wrong. So rather than being a number, we will set up and use another enum. So delete this for now. We come back to that and into our models and data. And here we will set up another enum. Now, our file here is going to start to get a little bit crowded. So we're going to kind of section this off. So this top section is all to do with our sides. It's the color of our sides and of the ball, but of the side as well. It is the order of colors for our sides, and it is the positions of our sides. So this here is all to do with our sides and technically the ball as well, but mainly the side. You know what, we say sides and ball information, okay? Then down here we add another comment, as this will be for our game state. And then we can really section this off to keep it nice and clear. Just make it as readable as possible. That would do. Okay, so we want another enum for game state. And anything that is of type game state now has to be set to either before game or in game. Okay, so how can we use that? Well, remember our new type is called game state. Command B to build because we are in another file. And now our current game state, rather than being a number, will be of type game state. We can just set this to game state dot before the game. So we're effectively doing the same thing as saying 0 and 1, but now we can literally read the words before the game. So we know the current game state is currently set to before the game. And when we move into the game scene, we will be before the game. So current game state will equal before the game. So how can we use that? Well, into our touches began. So when we tap on the screen, what we want to do is say if. If when we tap on the screen, current game state is set to before the game, do something, or if current game state is in the game, do something else. So what do we want to do? Well, if we're before the game and we tap on the screen, we want to start the game. If we tap on the screen and we're in the game, we want to spin the color wheel, okay? So what we want to do when we start the game, we want to spawn a ball and do some other stuff. So we will make a new function called start the game. And in here, we will spawn the ball. And when the game begins, we will update our current game state to now be in the game. So our code can clearly see we're in the game. We will delete spawn ball from here. And if we tap on the screen and we are before the game, we will now simply run start the game. If we tap on the screen and we're in the game, we will spin the color wheel. So let's break that down. We have a brand new variable called current game state. And at the moment, this will be set to either before the game or in game. We will have another option later on, but for now, it can only be set to before game or in game. And it will start off being set to before game, because when the scene loads up, we will be before the game. So what we're saying is, when we tap on the screen, if we are before the game, so therefore current game state is set to before the game, we want to start the game. So run the function start the game. Here we will spawn the ball and we will now update the value of current game state to in game because we have now started the game. That way when we tap the screen again, current game state will not equal before game. So therefore we can't restart the game. Instead, because current game state is now set to in-game, we are going to spin the color wheel. So now if we tap on the screen, when we're before the game, we start the game, which will include spawning the ball. And then every other time we tap on the screen, because we'll be in the game, we're going to spin the color wheel. Now what we actually want to do is have this as an else if. Because now what we're going to do is say if we're before the game, start the game and that's it. Because this is correct, don't even check this one. And that's important because if this is an if, what's going to happen is before the game, we will touch the screen. This will start the game, which will include telling our code we're now in the game. So by this point, at the end of this, current game state will equal in game. That means by the time we get to this, even though when we tap the screen we were before the game, our code now thinks we're in the game. So that will not only start the game, but it would also think we're in the game. Because at this stage we are technically in the game, and it will spin the color wheel. But we don't want both to happen at the same time, so else if. Now, when we start the game, because this is true, this one will not run. This will only check to see if we're in the game if on this tap of the screen we didn't start before the game. So now if we hit run, we will go into our game scene with no ball. We tap on the screen, we get a ball, and every other time we tap, as the game has now begun, we simply spin the color wheel. So if we tap on the screen before the game, we start the game and spawn a ball, but then every other time we tap on the screen as we're in the game, rather than spawning a ball, we spin the color wheel. So first time we start the game, every other time we're in the game, so if we tap, we spin the color wheel. So that's working fine, and that's working as we want it. But I don't know about you, if I was to get a game and this happened, just that, I'd be confused. I wouldn't know what to do. I mean, you'd probably tap sooner or later, but there's nothing on the screen that makes that obvious. So to finish off this start of the game process, we will make a label that will simply say tap the screen to start. And then when we start the game and spawn our first ball, we will delete this label. That's all we have left to do for this video. So back into Xcode. So we want to make a label that will be on the scene straight away. So we will add this to our scene in our did move to view. And then when we tap on the screen to start the game and we run start the game, we will delete this label. Now for this label, we are going to use a custom font. And I genuinely think, this might make me sound crazy, but I genuinely think a custom font is one of the biggest things you can do on your game to make it look so much better. Out of everything, I really think a custom font is the difference between your game looking very amateurish and looking very professional. So what we're going to do is we will download and we'll use a custom font in this project. Now in the past, I have just given you a custom font. which means it gets the job done. But this time we're going to go a little bit further. We will download the font that we want to use. So down in the video description, you will find a link to a font on dafont or dafont.com. This font is called Caviar Dreams, and I will see you there. And this is the one. This is Caviar Dreams by Thompson. And we just want the standard Caviar Dreams. I think it's a really nice font. I think it really fits this kind of simplistic and minimalistic game very well. So when you found your font and you make sure it is 100% free, and you have checked all terms and licenses to make sure you can use this font in the way you want to, we'll just simply hit download. And when you download this, you will get this, a whole bunch of TTF files. So we just want standard caviardreams.ttf, and if you click it and hit spacebar, it will show you the font. So this is the font that we have to use. And how much nicer is this compared to Arial or Times New Roman or Chalk Duster or whatever? It makes such a big difference. So we want to use this one, the standard one in our project. So what we would do is simply grab this and drag it over here to the left in our project. We want to make sure copy items if needed is ticked, because that will make a copy of this font in our project. Make sure this here is ticked and hit finish. So we now have caviardreams.ttf in our project. But just because we have this here doesn't mean we can use it just yet. What we have to do is set up this custom font so we can use it in our project. It's one of those things, setting up a custom font. It's quite easy when you've done it a few times, but the first time you do it, it feels like there's a lot of steps and a lot can go wrong, but it's not that bad, I swear. So what we would do to set this up, click on our project up here to go back into our home area. So this area here, and we want to go to build phases to come here. We want to go to copy bundle resources, and we want to make sure the TTF file is here. If it's not, it won't work. And if it's not, hit add and add it. So find it on here and hit add. If it is, then you're good to go. So after importing it, that's stage one. What we then have to do is go to our info.plist. And this is like a whole bunch of settings for our game. And some might look familiar. Remember on the home area when we said only let our game work in portrait? So we ticked the box for only portrait and unticked landscape left and landscape right. That made changes here in our plist. So as you can see, it only supports portrait. So here holds some of the important settings for our project, and we want to add one. So here, right click, add row for this new section, and we want fonts provided by application. Use a capital F at the start and it should find it for you. Here, we will open this up, and here we will type the name of any TTF files or OTF files, which is another kind of custom font that we want to use in our game. If you wanted multiple, simply hit add and you can have as many custom fonts as you want. We only have one, and here we will type the name of the TTF file exactly as it is here. So this is the file name. So item 0 is Caviar Dreams, capital C, capital D, .ttf. And when we run this, if the custom font isn't working for you, check here, make sure you have this right. So this has to be the exact same as this up here. Okay, and once we have that, we can now use the custom font in our project. So back into our game scene, and we will now declare and set up a label node to show some words on our screen. We will do this globally in the scene, so we can use this label in the did move to view, but then affect it and remove it somewhere else in our scene when the game begins. So globally, we will say let, and this would be the tap to start label. This will be an SK label node, so a label for our scene, and it will ask us what font we want to use. Here we say what font we're going to use. Now the important thing to remember is here we don't say the file name of the custom font. Instead we have to say the actual font name. To find that, right click on the custom font, show in Finder, open up the .ttf, and this here in font book, at the top here is the font name. So this here, Caviar Dreams, is what we have to use in our code. So here we will say this label will use Caviar Dreams, like so. Now, in a did move to view, we will set this label up and add it to our scene. So tap to start label. This will have some text that will say tap to start. This will have a font size, so how big the text is, of 100, a font color of SK color, and we'll use dark gray. This needs a position. of halfway across the scene and 10% up, and then just add this to our scene. So now we have made a label called tap to start label, which will use the custom font. It will have text that says tap to start, font size of 100, font color of dark gray, positioned halfway across the scene, 10% up, so it's right at the bottom of the scene, and then we added this label to our scene. So this will be on our scene straight away because it's in our did move to view. So hit run, and there we go. Our game now says tap to start. It's now very, very obvious what the gamer has to do when they move into our game scene. So now they tap and the first ball will spawn. However, our tap to start label will stay there. All we have to do is when we start the game, in addition to spawning the ball, is remove our tap to start label. So tap to start label dot remove from parent when we start the game. Hit run, and now when we tap on the screen, we get our ball and the label will delete. Like so. Now, that label just deleted out of nowhere. And I want these things to be really, really polished off and just to look as good as possible. So rather than just deleting, which looks a bit meh, we will make this label scale down to 0 and then delete. So whilst the ball is scaling in, the label will scale down. So, start the game. We don't just want to delete this. Instead, what we want to do, after we spawned the ball and made our current game state in-game, we want an action called scale down, which will scale an object to 0 over 0.2 seconds. We will run this on our label, and after it is scaled down, we want this label to delete itself. Otherwise it will stay on the scene even though we can't see it. We can do this with another action, so let delete label skaction.remove from parent. Any object that runs this action will delete itself. We then want a sequence, delete sequence, skaction.sequence, square brackets, because remember, this will be a list of actions that run in order one after the other. So we want to run scale down, and when that has finished, we want to run delete label, which will then delete this object. We will then take our label and we will run delete sequence. So now when we start the game, in addition to spawning the ball and telling our code we're now in the game, so next time we tap on the screen, the color wheel spins rather than our game spawning another ball. Our label will now run this. It will scale down, and when it has finished scaling down, it will delete. And that will make our label deleting look a little bit more polished. So now, when we tap on the screen to start the game, our label will shrink and our game will begin. So now we have a random coloured ball spawning in the centre of the screen. This ball will move to a random selected side and we have to tap to start the game. In fact, we have a lot more of our game in place than it actually looks at the moment. Because all we need to do now is to set up the contacts between the sides and the ball, and say when the ball hits the side, check if the types are the same. If they are, spawn another ball. If they aren't, it's game over. So we have so much of our code now in place. All we have to do now is set up the contacts between the ball and the side, and you will see this game really start to come together very quickly. So that wraps up another video. We now have our colour wheel all set up and we have the balls all set up. And we now have so much of our game in place. We now just have to take all of the bits and put them all together, and this game will come together pretty quickly. And that is what we will start to do in the next video, where we will set up the contacts between the ball and the sides. So in part 4 of this series, when a ball is hit a side, we will spawn another ball and we will code to figure out if the ball and the side match when they hit. But for this video, that is all. As always, thank you very much for watching. Leave any questions or any feedback down in the comments, or comment about anything you fancy really. Hit like, hit subscribe, and I'll see you next time. Goodbye.